Hi class, for this video what we're going to talk about is mutually exclusive and inclusive events and how they work with probability. Let's take a look first at inclusive events. Okay, so for two mutually exclusive events A and B, well what that's pretty much saying is that event A, it may be in the same idea area as event B, but event B and event A, they don't really have anything to do with each other and they don't affect each other. So for instance, one way that we could look at event A and B is, say we're drawing from a deck of cards, and I'm specifically interested in drawing two types of cards. One type of card is going to be a 4, and the other kind is going to be, let's say, an ace. Okay? Now, if I have a normal deck of cards and I take out the jacks, I'm going to have 52. So regular old probability will tell me that I'm going to put 52 as my total number of possibilities here. And then, well, how many 4s are there in a deck of cards? There's 4. Okay? And then the probability that I grab a 4 or an ace, well, grabbing an ace, the ace isn't going to really do anything to affect the 4, because if I'm only drawing one card, I'm either going to get a 4 or I'm going to get an ace. So I'm going to say that there's also a probability of 4 in 52 here. Okay, so from here what I can do is I can add these two together and my probability is going to be 8 over 52. Let's look at an inclusive event now. An inclusive event is when two events can happen at the same time. So for example, say I got these two cards that I want to look at here, and one of them is going to be a 4. Great. Well, we know the probability of drawing a 4, right, is 4 over 52. And I want to know what's the probability of drawing a 4 or drawing a spade. So there's my drawing of a spade. And cool, I know that a spade is 13 out of 52 because that's half of the black cards, right? Another way that we can look at this, though, is if we draw ourselves a Venn diagram. So here's one circle and here's the other circle. Okay, and then let's say that this side is for my 4s and this side is for my spades. Okay, and the number for spades is 13 and the number for 4s is 4. So that means that in this circle I have a total of 4, but in this circle I have 13 cards. Well, let's think about this for a second. Is it possible to have a 4 and a spade at the same time? And the answer is yes. And so that's an inclusive relationship right there between these two things. Two things can happen at once. Knowing that I have 1 here, well, to get the 13 total, that means that I have 12 on this side. And on the other side over here where I'm looking for 4s, since I already have 1 here, to get 4 total, I'm going to have 3. Okay, so what that means now is if I add all of these up, 12 plus 1, that's 13, plus 3 is 16. My probability is going to be 16 over 52 as the total sets of cards. But when I look at this setting over here, let's grab a different color. When I look at these guys right here, that equals 17 over 52. So what's the deal? What we forgot to do is subtract the one difference, or instead of subtracting, we just added twice this 1. So what we ought to do now is do minus 1 over 52, and that's the difference. And there's that difference when you have an inclusive relationships when things overlap.